So I've decided to make the transition from Eagle to KiCAD for a couple reasons. The biggest being I can't do larger boards. The free version of Eagle limits me to like a 10 centimeter by 10 centimeter board, or yeah, 100 millimeter by 100 millimeter. And I wanted to do a bigger board, and it seems as though that's going to maybe be something I want to do in the future, and I should only want to have one CAD program in my head. Learning a new CAD program is really painful. So, yeah, I've avoided KiCAD in the past because it was a little bit flaky, I thought, and it seems like it's gotten pretty good now. So I decided to make the transition. So let's take a look at my schematic here. It's nice that it's framed. You can pick different size title frames, and so there's kind of everybody kind of does it in KiCad, make these little square rectangles around certain parts of your schematics. I went ahead and did that. This section here is for the audio oscillators, so I have 3 of these audio oscillators. I kind of like the op amp symbol. I like the yellow. And then these are the low frequency oscillators. Here, the same thing, just a larger capacitor. Here is my my noise generator. And over here is my mixer. People have commented about you really don't need these op amps. That's true. If you have a low impedance input to these things, this is superfluous. You really don't need this. I just kind of wanted to make this real generic, and I kind of like the way it looks symmetrically with 4 op amps. And this just gives you a high impedance on the input and then a very low impedance on the output. So these 10K, 10K, 10K will be the value they are. If this isn't here, then each of the summations will have a slightly different magnification due to the variation of the impedance on the wiper of your potentiometer. This is where all of the op amps get its power, plus minus 12, and here's where the bypassing is. So all of the stuff here down at the bottom. One of the things I kind of find annoying, but I guess it's just the way it is you have to create mounting holes on the schematic, not on the PC board. But whatever. Let's see, what else do I have in here? I've got my Roland ladder filter. So I went ahead and kind of combined a couple things. I put in the same current generation as was in the voltage controlled amplifier section. I said, hey, if it works over here, great. You know, I've tested this before and it works great. I'll just go ahead and put it over here. Well, you should breadboard things before you design them, because this will just not work. If we take a look at this over here, the current flows from left to right. It flows through that 22K into ground. And that means that the current will continue on its merry way through R39. It'll go through 1 and 3. So there'll be a little bit of current between 2 and 3, but majority of the current goes between 1 and 3. And the current will go into the device. Whereas on this filter, I want it to be going in the down direction. And so this thing just won't work at all. So I'm gonna have to cut and patch that as soon as I get the boards. That's kind of a shame. The other thing I did without breadboarding is these 1K resistors on the bases of the transistors here. I originally had them ground referenced, and then I had the current going to a negative rail, and I've gone ahead and biased them up a little bit. This is the same thing as what the Moog filter is doing. Yeah, so I'm hoping that's okay. I can always go back to changing things a bit. But anyway, let's see what else I did here. I did learn how to do part creation in KiCad. So one of the first parts I did was to create a CA3046, which didn't seem to exist. So I had to create my own symbol, and it's a multi-part symbol too, right? There's this is a double part here, and then there's a couple single ones here, and then there's an extra single one over here. So I had to make a multi-part device, and that was pretty straightforward. I stumbled a few times, but I was able to make that now. So I kind of like that library feature. Let's see here. This part was in the library. The audio amplifier is the LM386, and then the voltage controlled amplifier is the 3080, and this was in the library. Okay. The other thing that I did was create some patch areas. Like here, the mixer has 3 inputs. So if I just put a jumper straight across to one of those little shorting blocks, I can put oscillator 1 into mixer 1. If I put the shorting block here, I can put the square wave into the mixing block. Like down here at the bottom here, I can put the square wave 3 into the mixing or the noise source in the mixer. So I don't need to have jumper wires. I just need to have little shorting blocks. So that's kind of fun. There's an area here where the voltage control filter can be modulated by either the LFO1, the square wave, or the envelope. If I'm going to do this board over again, I forgot to put in, it needs to just have a potentiometer, just run this thing off of a voltage. So you can set it just with a potentiometer. So just completely forgot about that. So that would be a good thing to add. Here's a little jumper area for the voltage controlled amplifier. Again, it can be controlled in different ways. And then on the output, basically you usually have the mixer going into the filter, and then the filter going into the voltage control amplifier, and then that going into the final amplifier. So you just put a jump here, and you kind of have a normal configuration. But because they're on headers, you can jump things all around and do things differently. And then here is an envelope generator. This particular synthesizer is just a one-note synthesizer. It doesn't have a voltage-controlled oscillator, and it doesn't have a keyboard or anything like that. It's going to have one key. You push the button down and it'll make a tone, but you can change the envelope on that tone. So there's an attack and a release on this thing. All right, so that was the schematic. And this is the reason that I wanted to use KiCAD, because I have a big board now. This is about a 5-inch by 5-inch board, and it's going to have everything on it. So let's kind of take a look at this board. Down here at the bottom is oscillators 1, 2, 3. So these down here, these are my lows, low 1, low 2. So all the oscillators along the bottom. Here's my noise source over here. No, sorry. This is my noise source over here. What is this over here? Oh, this is the final amplifier over here. This is the LM386. Goes out to the speaker. This is the envelope generator, attack and decay. Here's the mixer, channels 1, 2, and 3. Then here is the filter. And then the voltage controlled. Let's see, a voltage controlled amplifier is right here. So the VCA is down here as well. And here are those little jumper areas. So anyway, I'm pretty excited about this board. It's being fabricated now. So yeah. So my impressions of KiCAD is it's quite capable. It'll do what you need it to do. I have 2 main gripes. The first is you have to use 2 hands at all times in order to lay things out. You have to have one hand on the mouse, and you have to have one hand on the keyboard, hitting rotate, move, things like that. When I was laying out in Eagle, it was very, very rare that I needed to use my second hand. I could do almost everything from the key, from the mouse. The right button seems to be context sensitive in Eagle. So if you grab a part, it knows what you want to do with it. When you hit the right button, it says, "Oh yeah, you want to be rotating at this point in time," and then you put it down. Then the left buttons become something like, "Oh yeah, you want to move it this time, don't you?" Anyway, just a minor gripe. It does require you to have 2 hands, and it's a little bit difficult for me to do in my office. So I ended up doing most of my layout in an easy chair with a laptop in my lap. Because then I can have both hands on it, and it just seemed to work out better. But anyway, like I said, minor gripe. So, like I said, this board's going to fail from the get-go because of a couple errors, but should be able to patch this thing up and get it to make some tones. And once I get that up and running, I'll go ahead and release this board and basically be done with the project. I kind of am going to stop there. No, I'm not going to make a VCA. I mean, a voltage control whole system with a keyboard or MIDI input or anything like that. My intent was never to build a synthesizer. The little Moog synthesizer that I bought is fine. Just go buy one, or buy something off the shelf. There's a whole big community that does all of these DIY things. I'm not interested in doing any of that. I basically just wanted to learn a couple circuits, have some fun doing it, and teach you guys something along the way. We're going to learn about just a couple ways to use op amps. There's some transconductance amplifiers that are kind of interesting. There's this really bizarre filter that was totally fascinating. Some people were interested in the noise source that I did. I might expand that a bit in the future to have pink noise and blue noise and stuff. That's just adding filters, limiting the spectral response of the white noise. But yeah, so far so fun.